Michio Kaku has even claimed that the James Webb Space Telescope has spotted 6 massive galaxies that scientists previously believed were impossible to exist, as part of his unusual duty to the domains of material science. It's possible that these observations will lead to fresh insights into how the cosmos works. The finding challenges accepted theories regarding the formation and evolution of galaxies, and is both groundbreaking and empowering. Therefore, it is worthwhile to monitor these updates. The fact that such a reputable expert confirmed it emphasizes how important these disclosures are. A physicist of American and Japanese descent, Michio Kaku is a remarkable character in science. He is considered an authority on both quantum physics and classical exploratory material science. Kaku has been open to the amazing findings of the James Webb Space Telescope mission, in contrast to some more conservative and skeptical scientists. His eagerness to accept and disseminate new findings demonstrates his dedication to expanding our knowledge of the cosmos. We are pleased that this renowned scientist has made the decision to speak out and openly express what is now undeniable. The well-known physicist's enthusiasm and laser-like intensity are evident in his remarks regarding the James Webb Space Telescope's findings, suggesting that this has been a characteristic that has captured his attention. Come discuss the ramifications of Michio Kaku's discoveries about these 6 enormous galaxies. Throughout his life, Kaku, a researcher, has consistently been able to consider novel theories. Realizing that Newton's laws and Einstein's theories of relativity, although basic, are unable to explain the complete complexity of the cosmos, he has demonstrated receptivity to ideas that question the current quo. Although many of his colleagues have not yet embraced this perspective, Kaku believes that the new telescope's discoveries have the potential to further the discipline of cosmology. Both quantum mechanics skeptics and Big Bang proponents have been troubled and worried by this. But all this does is make Kaku giggle. 6 massive galaxies that date back to the early universe have been discovered by the JWST. Even though they developed between 200 and 700 million years after the Big Bang, each of these massive galaxies has more stars than the Milky Way. The group of space scientists that discovered these amazing galaxies have dubbed them universe breakers, because if they are verified, they would fundamentally alter our conception of the cosmos. These findings have important ramifications, indicating that the early cosmos was far more robust and complex than previously believed. Something no longer belongs here. The universe was chaotic following the original event, according to the theory of how things came to be. It took a very long time for the first solid objects to form, and it took even longer for them to become dense enough to emit light. It was thought that complicated structures like galaxies would arise considerably later. Some of the recently discovered galaxies are larger than the Milky Way, and their extreme brightness indicates that they were probably producing a large number of new stars annually, whereas our galaxy only occasionally produces stars. Scientists have not yet been able to pinpoint the exact moment that the first galaxies formed. There is only one thing that is certain. Before dwarf galaxies nurtured little cosmic frameworks that developed throughout time, there may have been only a single star or a collection of stars that later joined to build larger structures. The topic of whether the universe is much older than previously recognized or whether sophisticated astronomical structures formed much earlier is raised by the belief that extremely enormous and massive galaxies could not have existed at that time. Conservative science, which continues to identify problems with this concept, finds this scenario difficult to accept. Numerous facets of physics have specifically denied this finding and raised concerns about potential inaccuracies in the age calculations. Because of the influence of some experts, there are many models of outdated and false theories that obstinately continue to exist. Kaku is aware of this. It wasn't until substantial investigation demonstrated the shortcomings of many of these hypotheses. As a result, the experimentalists who keep the researchers informed and vigilant are crucial to any science, but particularly to physics. As a matter of fact, we on Earth know very little about the universe's true beginnings. This quote from Kaku emphasizes how crucial ongoing testing and verification are to the scientific method. Based on observations of the universe's expansion, the theory of creation was developed in 1927. The cosmos started at a certain place and has been expanding ever since, according to the evidence. People and scientists at the time found it difficult to envision a universe with a beginning and an end. Humans could not have imagined a cosmos that was vast in extent and had existed forever. Scientists are still trying to figure it out. Even though these new findings contradict the Big Bang Theory's long-held assumptions, it is nevertheless important to take these alternatives into account. Reevaluation and receptivity to new ideas are essential components of the scientific process, as science has repeatedly demonstrated. The idea that stars and planets were permanently fixed in the universe and that their particular configurations occupied a specified space was previously accepted, much like the acceptance of several theories and discoveries when Einstein was a young man. We now know, however, that everything in the universe is moving. Planets revolve around stars, stars travel many kilometers per second within their galaxies, and entire galaxies travel quickly through space, the fate of which we are yet unsure of. This extraordinary comprehension of the cosmos calls into question long-held assumptions and emphasizes the necessity of ongoing research and evolution in scientific theory. Scientists nowadays face difficulties in accepting unsettling realizations and realizing that hypotheses are not infallible until they are thoroughly examined or validated by precise observation. The discovery that galaxies are moving apart and that this distance is proportionate to their separation from Earth gave rise to the idea of the Big Bang. The universe was thought to be expanding over time based on this discovery, which is known as Hubble's law. This theory seems to be supported by cosmological patterns, cosmic background radiation, and the redshift of light from distant galaxies. But it's crucial to keep in mind that, prior to significant events or advances in technology that painted a better picture, those who held the views that the Earth was flat and the Sun revolved about us also had observational data to support their claims. Similar circumstances are currently in play. Scientists had hoped that the new James Webb Space Telescope would dispel skepticism about the Big Bang, but instead they have come across these 6 galaxies that seemed unattainable. This demonstrates how science is always changing and how researchers need to be receptive to new information and reevaluate pre-existing theories in light of new data. The unexpected findings cast doubt on accepted knowledge and force a re-examination of long-held cosmological theories. Redshift is a tool used by researchers to calculate several measures in the study of the universe. The Doppler effect, sometimes referred to as redshift, is the term used to describe how light changes color as observers and light sources move in relation to one another. Imagine hearing a car approaching while you are motionless to get a sense of this. The engine sound increases in volume as the car approaches, but it alters as it passes you or travels away. The reason for this is that when the car drives, the sound waves alter. The same is true with light. It changes to bluer hues as a light source, such a far-off star, approaches us. On the other hand, the light changes to redder hues as the light source gets farther away. We refer to this phenomena as redshift. Redshift values have been translated into rates and lengths by physicists for use in measuring the universe. It is important to remember, though, that even a tiny inaccuracy in these measures might have a big effect. We are now reviewing the measurement techniques that were previously employed. It is necessary to examine whether the most recent findings about our cosmos are actually the result of redshift errors, or if certain scientists are merely ignoring the truth. This is a question that has to be carefully examined, and the facts and research methodologies must be thoroughly reviewed. The continuous study and reevaluation of measurement methods demonstrates how scientific research is a dynamic process. Thank you for seeing the video. We remind you to leave your questions in the comments section as usual. To help the video reach more people, please hit the like button, share it, and subscribe to the feed. This will ensure that you don't miss any future videos like this one. I appreciate you watching, and I hope to see you in the future one. By encouraging viewers to interact with the content, this call to action cultivates a community of inquisitive minds ready to investigate and comprehend the most recent scientific debates. Scientists from all around the world are still fascinated and challenged by the investigation of our universe, with its enormous distances and intricate celestial bodies. Every new discovery, from the first hypotheses about the universe to the most recent ones made possible by advanced technology, changes our perception of the cosmos and pushes the limits of human knowledge. The genesis and evolution of galaxies are among the most important and enduring problems in cosmology. Galaxies are gravity-bound cities of gas, dust, stars, and dark matter. Deciphering the formation and evolution of galaxies is essential for both solving the mysteries of our universe and validating or testing accepted hypotheses, such as the Big Bang Theory, which explains how the universe came into being. According to the Big Bang Theory, which was put forth almost a century ago, the universe started as a single, infinitely dense point and has been expanding ever since. The cosmic microwave background radiation, which is thought to be the remains of the early universe's extreme heat and light, and studies of the universe's expansion gave rise to this theory. Recent findings, especially those from the James Webb Space Telescope, have called into question a number of fundamental tenets of the Big Bang Theory, though. With its exceptional sensitivity and resolution, the JWST has discovered galaxies that seem significantly more massive and developed than would be predicted for their age. One such finding includes 6 huge galaxies that were discovered between 200 and 700 million years ago, which is a very short time in the universe's 13.8 billion-year existence. Because of their size and brightness at such an early cosmic age, these galaxies, dubbed universe breakers by the research team, challenge accepted wisdom. Age. These galaxies' finding defies accepted theories of galaxy formation and poses fascinating queries regarding the early universe's quick evolution. Galaxies are thought to form gradually over billions of years through the accretion of gas and stars and the merging of smaller structures. These huge galaxies' early cosmic history points to a far more intricate and maybe quicker galaxy development process than previously believed. The revelation also emphasizes how important technology developments are in changing how we perceive the cosmos. Astronomers have been able to discover hitherto unobservable facets of the early evolution of the cosmos because to the JWST's capacity to look farther into space and record weak light from far-off galaxies. These studies shed important light on the circumstances and mechanisms that controlled galaxy formation in the early cosmos. These findings have ramifications that go beyond cosmology. They push researchers to re-examine and improve current cosmological models in order to better explain the observed complexity and diversity of galaxies over cosmic time. They also highlight how scientific knowledge is dynamic and ever-evolving, with new findings having the power to alter preconceived notions and lead to fresh lines of inquiry. The study of galaxy formation is still a dynamic and expanding field of study as researchers continue to examine and interpret data from the JWST and other observatories. We are getting closer to solving the enigmas surrounding our cosmic beginnings and comprehending the fundamental mechanisms that have molded the universe into what it is now with every new discovery. In conclusion, the discovery of these 6 huge galaxies marks a significant turning point in our quest to understand the cosmos, even though it also calls into question our current understanding of galaxy formation and the early universe. Such findings broaden our interest with the vast and complex fabric of the universe and open the door for future breakthroughs by stretching the limits of scientific understanding.